Yeah, sorry for the delay. We can get started. Let me introduce Dr. Pavi. So Dr. Pavi is she's a lead at at the Ghosh group, and she has been specializing in machine learning, and she is currently a lead at machine learning team at Drive, which is a unit of Ghosh. She's currently focused on advancing the proof of concept to that of more like a scalable and readily deployable solution. She's also responsible for the technical vision, particularly focused on multiple areas. If you take the ML domain, there is NLP, you have computer vision, as well as more recently the agentic workflows plays a very important role. She is also working on those areas. Her core expertise is pretty much in directing the implementation of the robust and modular solution, and basically just to translate those complex unstructured data into meaningful outcomes, because that's a critical part of any machine learning, right? Because the data, even though it's available in different forms, structuring it and then getting the meaningful outcome is the most important thing. And mostly she's focused on how to improve the patient care and the experience. And today, as the topic suggests, she's going to focus more on beyond accuracy, because this one challenge any domain has, and she's going to focus on how specialized agents are being used in healthcare. With that background, thanks a lot, Pavi, for agreeing to present this session to us. Looking forward to an interesting session and discussion. Over to you.
Thank you so much, Prem. It's lovely to be part of this community, and thanks to everyone who's come in to listen to this discussion. I know it's a bit, as I told Prem, not very attractive like what you find in the corporate world, right? But it should be interesting. So let me go over to the topic. So what I'm gonna be discussing today is how we need to look beyond, like the standard performance metrics. And it's not just about AI agents, right? Anything to do with AI solutions. If we were to deploy them within a healthcare setting, what are the challenges? What are the, why we need to think beyond just the technical aspects when you have to push things into deployment within healthcare. So what I will do is I'm gonna be off camera, Prem, if it's fine, because my internet seems to be lagging.
Yeah, that should be fine.
Yeah. Apologies. So I'll just give a brief introduction. So Great Ormond Street Hospital is a hospital within United Kingdom. It's part of the National Healthcare Organization, also known as NHS. So this is a hospital where children with rare disease and complex conditions are treated. And where I work as part of the Drive unit within the hospital, which is called as the Data Research, Innovation and Virtual Environment. So the vision for bringing the Drive unit into Gosh was, there's the need to kind of leverage data and technology, but how do we do it? How do we kind of bring in, like clinicians, ML scientists, data engineers, industrial partners together into one space? So this is the vision for, for Drive, and it's also kind of to make sure that Gosh becomes the go-to center for pediatric innovation. So now moving on into why is AI adoption in healthcare always challenging? Why is, like the moment you talk about AI or bringing in AI solutions, why does it always seem much more challenging compared to other sectors? So if we kind of take a holistic approach to this, one of the main things is the utmost important thing I would say is to ensure that it is always patient-centered care. So anything that we do should have an impactful outcomes that provides better outcomes for patients. And this means any solutions that we want to bring into healthcare requires a direct oversight of experienced healthcare professionals. So we need to ensure that it is not autonomous. We need to ensure that it is safe and reliable. So how do we make it safe and reliable is whether it's about us building the in-house solutions or bringing solutions from outside. How do we ensure that we have the stepwise implementation? How do we ensure at every stage, right from the development to deployment, we've done like rigorous evaluation, validation, and it doesn't end there, right? Once you know that your solution is ready to be deployed, what does that mean? So there's a level of commitment that needs to be considered, like how do we continuously evaluate, how do we optimize these solutions, how do we improvise them, with the pace at which these developments, especially in the LLM space, is happening now. How do we ensure that we also kind of optimize these solutions? And the most challenging of all of these is how do we ensure that we have the proper information governance and security guardrails? So this is kind of the most I would say challenging part, because you need to ensure that your data is protected, your data is secure, the privacy is, like considered cybersecurity compliance. So there's a lot of governance around the solution that goes beyond just thinking about, okay, I have this AI solution that works. It doesn't end there. So there's a lot more to be considered here. But as a technologist, if I were to just look at like how do we build solutions, push them into piloting, what are the challenges? So there are some of challenges that our team has faced would be one, I would say is we know that there's a large volume of data available within these healthcare systems. Now with digitization, we are able to kind of, access these data, analyze them, you make it into a usable format. But why is it still a problem? So I think the focus needs to shift from data quantity to quality. Even though we have all these large language models, all the AI solutions that are being brought into now, it still lacks the real world meaningful data. So what we need to understand here is healthcare data, especially the real world healthcare data. It's very, very messy, very inconsistent, and very unstructured. So what would best help is what we've learned from our experiences. We need to benchmark and refine these real world clinical data. We need to ensure that we have these benchmarking data set so that we are able to kind of compare the models, the solutions, and also understand the drawbacks around it. And some of the biggest barrier, I would say, is once you have a solution, once you have piloted it, once you know that it is kind of good enough to be useful, how do we start ensuring that it is reliable? How do we make sure that the clinician who uses that understands, okay, there is some safety issue with this model, but how do we ensure that the clinician would know why this has failed, why this has happened? And I think it is more critical as technologists, we need to start thinking about how do we make these black box model reliable? What do we do in terms of post-deployment monitoring? If we are going to start using these language models or visual language models, would mechanistic interpretability help us to kind of understand how these models, like analyze the data? So there's a lot of open-ended questions here that we need to start addressing. Right. I know when Prem was asking me to do this presentation, I was like, what do we do about agents or workflows? But you might have seen him give an extensive discussion in one of the previous sessions. So this is more about, this is still a gray area for us. So if we talk about agents, do we want to look at something that is autonomous? So that's kind of very, very, it's not a safe way of implementing such things in the healthcare setting. But if we look at workflows, yes, workflows would start helping. But how do we start there? So in order to do that, we need to understand how we will be deploying these AI models or AI solutions. How does that work within the healthcare setting? So the next few slides, I'm gonna take you through the journey of how we started to kind of work from scratch with no infrastructure and where we are now. Right. So when we started to work on language models, so what was interesting for me was I moved from a corporate sector into the NHS. So it was a very, very different world. The way you work in a corporate sector is completely different from the way you work in a public sector. And what was very, very interesting was you have, like you have all these large volumes of data. There's so much of potential to bring in AI to help clinicians, to help the staff, but where is the infrastructure? So we had to build our own infrastructure. We have our on-premise infrastructure. And at that time, we did not have access to GPUs. So our on-premise infrastructure was within the Gauss network, completely secured, and where we were able to run models, we had no access to internet. So this means that there are two things here. One, we need to ensure that we use as much as open source tools as possible, and two, like trying to use external APIs is a bit of a risk. So we were bound to kind of focus on how do we leverage open source models? How do we leverage the academic research? How do we bring them? How do we start building proof of concept? And we started to explore these small language models. And over time, I know initially there was a huge gap in the performance between the SLMs and LLMs, but over time, the performance, the quality versus the size of the model seemed to improve, at least on all the open source external benchmarks. What we found was these small language models were very good for simple, straightforward extraction. Let's say you have a lab report, you want to extract something from the tables in the lab report, it was quite good. What was also good was, because clinicians are very, very busy, it's quite difficult to get ground truth labeling of all these data. So these models were performing very good as zero-shot predictors. So that gave us like a first stage of progressing. Okay, we have these data. Are we able to use these SLMs in a CPU with a CPU compute? Yes, it was quite good in extracting the information. But however, it does suffer from hallucination. You cannot completely rely on them. And the other thing was, yes, we are able to extract information, but how do we explain? Where is that explainability component? And also, what we found was, while we try to stretch using the CPUs, it is not scalable. It might be good to kind of showcase a proof of concept, but it's definitely not a feasible solution. So this is when we started to think about, and now we've invested in GPUs. We have our in-house H100s within our on-premise infrastructure. So moving on, I'm going to talk about the first use case, like why healthcare data is challenging, why it is difficult, and also why we need to think beyond just the technical aspects of, like looking into the architectures or building these AI solutions. So one use case was where we were working with a senior oncologist, a clinician, to try and understand. We have these large volumes of histopathology reports. Are these information present elsewhere in our EPR systems? And when we found that, okay, it is not present anywhere, how do we make it useful for them? So this is where we did a short internship work with a student who was looking into histopathology reports, very specifically on renal biopsy reports, again, trying to understand how much can we stretch the usage of small language models. So let's, if we want to look at the clinical context, what a pathologist would do is they would extract a biological tissue sample, they would stain it, and they would analyze it under the microscope to try and understand, and whatever they've found, whatever they've analyzed would be found in this histology reports. And why would this information help is this report, it is filled with vital clinical data, and this is only present in the form of unstructured data within these reports. So over time, if we are able to extract such key structured information, it would allow clinicians to start using it in a more usable format. So for example, let's say if a clinician wants to understand how many patients had a biopsy, the only way they could do now is to look through these reports individually. And to talk about why clinical data is complex, and I'm not from a medical background, so I'm a complete technologist. So for me, it was like, in order like in order for us to build these solutions, or if we want to ask these SLMs to extract information, we need to understand the complexity of this data. What is it exactly that we are asking the AI to do here? And what we did was we spend time with the clinician to try and understand the clinical domain in order to uh, like build guidelines and provide information to these language models. So if you can see on the right hand side, as I said, I'm not from a medical background, but this is how we used to sit with the clinician and try and understand the clinical domain. So when we look at the kidney anatomy, we know that there were two key components. And what we want to focus from the report was try and understand around the native biopsies, the transplant biopsies, what would be the primary indicators of damage. And as we were doing this, and as we were trying to kind of understand the information, and while we were building this tool, what we found was, for example, if you look at the entity type, like if we want to understand whether a cortex or a medulla is present, we know from the clinician, we know that this information is binary. Is it a yes or no? But is it straightforward in the reports? That's the challenge. So what we gathered as a guideline was, if either of them was mentioned, like if cortex was mentioned, then we need to imply that medulla was absent. But if neither of them was mentioned, we will have to assume cortex. And I think this is where the domain knowledge, understanding the clinical knowledge, understanding the clinical pathway, the workflow is very, very important for us while we are building these AI solutions. And moving on to how did the SLMs work? We stretched it a lot. We tried a lot of experiments, and but then here we were working mostly with non-medical small language models. We found that with the help of the guidelines, where the information was quite straightforward, the model was able to do. Most of the models were able to do well, but where it failed was especially in extracting the final diagnosis from these reports, which does show that it needs more context, it needs more inherent medical knowledge, and we felt that these models were not yet ready to be scaled, at least for extracting information like the final diagnosis. The next use case, this was something interesting, is we were doing a project with the quality improvement team. So the quality improvement team wanted to kind of understand within the hospital, has there been an increase in the number of fractures that happened for patients who've come to GOSH, and they wanted to kind of start recording and monitoring, because they want to understand if there is an increase, what are the changes that need to be done? How do they inform the staff and the clinician? And as they were working on this, they had lots of other data, like they had looked into incident reporting, they've looked into the structured information. But what they found was the source of truth to understand whether an inpatient had a pathological fracture when they were within the hospital was only found in radiology reports. And this means they had to do this manually. They need clinical expertise, which means they have to spend months and months looking into these reports. And again, this is not scalable for them, which is when they came to us on how do we automate this as an operational tool. And initially, I was very, very skeptical. I told my team, like, we should try and aim to build a solution that doesn't look into LLMs or SLMs, because then the generation component would be less risky. Let's keep it as a classifier tool. But as we tried building our own solutions, there were lots of challenges that we faced. And one of the main thing, because this is about rare disease, it was quite challenging to build classical solutions, because it does, every time we try to run it on prospective reports, it would fail. It would kind of degrade, the performance degrades. And the other thing is, how do we make it more explainable for the clinician to understand? That was another challenge. And what we did was, at the time we were working on this project, Google released an open source model called MedGemma, which was trained on medical data, and it had that inherent knowledge. And it was very, very sophisticated compared to the other small language models, like the general Gemma model, the 5 models. And before I move on to using MedGemma, as I said, some of the core clinical challenge, which is not just for this project, but in general, any work that we do within the healthcare setting, what we found was the data distribution was a major issue, because in this case, the clinical safety incidents are often rare. And of course, being in the hospital, clinicians or staff do not want it to increase. You'll always find this extreme data imbalance within the clinical records, which is not a good thing if you're building machine learning tools. And because of this, no matter how much we tried training like supervised ML models, like using few shot approaches, it still did not make these models reliable, and it was quite impractical to start piloting them. And there was also lots of sacrificing the accuracy or missing critical events as we started to kind of test it on prospective data. And the major issue, what we also found, because as I said before, because it's about rare disease, you'll always find the out of distribution data an issue. So this is where MedGemma, the open source medical model, helped us specifically to navigate this rare disease context. It was quite good in extracting structured evidence, which also helped us to kind of explain how we reached to the solution. And also it enabled us to provide more transparent reasoning chains. And this has been, let me go to the next slide. Okay, so to go a little bit more deeper into the technology, so what we tested was using MedGemma as a zero shot did not help much. It did help, and it did have the inherent medical knowledge, but it was still not able to kind of understand what the clinician wanted, because they were very specific on not looking at healed fractures. They did not want external fractures to be included. So these type of clinical nuances required us to use a few short chain of thought reasoning. And this did help us to improve a lot. We were able to identify a lot of the reports that did have pathological fractures. And as I said before, this is still a language model which is prone to hallucination. It is still generated text. So how do we ensure that if we were to push this into deployment, how do we ensure that we are able to at least understand that this information has been hallucinated? So this is where what we did was, there was another open source model from Microsoft called Medify. So it is not as big as MedGemma, and it might not be very good with the reasoning as MedGemma, but it could definitely help us in understanding whether whatever factual information we've got from MedGemma, how do we verify this? So we used MedGemma more as a factual verification tool by using natural language inference. So we kind of hypothesized the original report as a hypothesis, and we considered whatever was outputted from MedGemma as a set of premises, and we tried to generate outputs whether the premises were actually entailing or contradicting the original report. So we kind of use this as a component for factually verifying. So the next step now for us is we want to try and understand whether this information would also help the clinicians while they are reviewing these outcomes. A bit more deeper, as I said before, this is more about the steps, and I wouldn't say this is exactly an agentic workflow, but this is the way we've approached it. We could call it as a very simple agentic workflow, because we want the model to kind of rationalize, pick the evidences, and then make a decision. So maybe this could be like, I know it's still a gray area, so I wouldn't call this as an agentic workflow yet, but it's definitely could be like a simple agent within a workflow that could be, like expanded in the future. And in terms of the operational impact, so this is one of the first our agent-driven tool. I would say that we've started to pilot since September 2024, and we've definitely seen a lot of improvement. One is now the clinician initially has to spend like 5 days or 10 days looking through this report. They could just take around 15 minutes to look through, because we are able to kind of filter out majority of the reports where you don't have any pathological fractures present. The other thing is the use of MedGemma. We were able to achieve not just like a 91% specificity, but also a higher recall. This means we were able to make sure that we don't miss much of the reports that had the pathological fractures. And it's all done within the hospital infrastructure. Everything is run in a server that has no access to internet, and quite safe. And everything is kind of, when we provide this to the clinician, we also provide them with the explainability, the rationale that is produced from the MedGemma, and we are also kind of collecting the feedback from the clinician. So to understand how the perform, it's not just about the performance, but also on whether they think MedGemma is uh, so one of the main things the clinician wanted us to do was to ensure that these LLMs do not infer anything on its own. So that's something that we've made sure that when we do the few shot prompting, we make sure that the MedGemma component doesn't infer on its own using its inherent knowledge. It's very much bounded to the radiology reports. And so far, based on the feedback that we've got from the clinicians, it is doing quite well. And mainly to also say that because this is about rare disease, it's also able to capture a lot of the out of data distributions, as I mentioned earlier. And yes, so at the moment, now that we were able to kind of pilot it in an on-premise infrastructure, we feel that this could be like a multi-agent architecture that could also be useful for other organizations. This should be adaptable in other pediatric hospitals. And one last thing is, as every AI solutions that we build, this is not to replace clinical judgment. It's more to augment and help streamline their existing workflows. And then, so moving into production, so what are the steps that we still need to push these things into productions? Not about agentic, but in general, if we think about, if we were to push these ML solutions from the piloting stage into production, I think the main core areas where we are now currently working on is how do we make it more explainable? So the explainability is not just from the technical perspective, right? It's also from a clinical delivery perspective. So how do we ensure that it aligns with the clinical workflow? So if we take the histopathology reports, for example, if the clinician would want to look through these reports in the form of a decision tree, how do we ensure that the models that we build also align with this? And also from a technical perspective, how do we kind of understand whether these models are performing the way we want it to perform? And the other thing, what we are also now looking into is with the rapid use of all these LLMs, VLMs, there's this challenge of how do we interpret, how do we know that, okay, it's come to this particular outcome, but how do we ensure that internally these models are looking into the right information. So this is where we are also looking into whether the research happening in mechanistic interpretability. If we are looking into the internal functionalities of these models, interpret them, would they help us to represent better outcomes? And the other thing that we've also looked into is post-deployment monitoring. Once we deploy these solutions, it means it's not about the traditional way of how we follow in machine learning approaches is we have a static test set and we start testing it out. Once you push it into production, you have these large volumes of data that gets processed through these pipelines. Do we want the clinician to look and check each and every step? And that's definitely not possible. That's not scalable. So from a technical perspective, how do we ensure that the data that we provide as outcome has been monitored? And we've been looking into what is called statistical quality monitoring, trying to understand how the different metrics of different components of our pipelines would align with how we've got the ground truth from the clinicians. And I think these are the three main areas where we are now focusing on is once we build these pipelines, if we want to push them into production, how do we ensure that we have all these components in place? And of course, one of the main challenges, at least for me as a technologist, was building these pipelines is we can do it, but how do we ensure that clinicians are able to adapt and use these solutions is to understand on how we bring a user interface. How do we ensure that the end users are comfortable using these solutions? And of course, this is not a work done by a single person. So we have, thanks to my entire team and also the wider team, we have our infrastructure, the engineering team, the data science team, who all been helping to build and bring these solutions into life. Thank you so much for listening. I hope it was useful.
Yeah, it was pretty good. Thanks a lot, Pavi. It was quite a different view because always we have been dealing with technology. Applicability is the one area that always introduces us. So I do have a couple of questions. So this is more relevant to that of data security. Because one, I mean, based on some of the discussions with my friends, they always say that getting AI into healthcare is one of the biggest challenge, right? So do you, by any chance, obfuscate the data so that you can remove the uh, patient-specific information, then just focus on only on the, I would say, the core part of it? Of course, it comes as part of the data cleansing, but just want to understand more on that.
So in terms of Drive, like before I joined Drive, the main purpose of Drive was to ensure that they de-identify and have the data, the structured components ready for people to use. So we have our own what you could term as the trusted research workspace, and we have an external company who kind of helps us to uh, maintain the workspaces. So we have two workspaces, the research workspace and hospital workspace. Research is where people are allowed to access de-identified data.
Mhm.
And hospital space workspace is where you're able to access identifiable data. But this is quite mature for the structured space. In terms of unstructured data, there's lots of governance around it, right? So we do have our own de-identification pipeline, but then it's more restricted to the Drive users at the moment. Because we have the on-premise infrastructure, we've kind of work only on it. We don't use it heavily in the workspaces because there's the challenge, like the information governance team could come back to us saying, okay, you have this de-identified pipeline. We are dealing with kids with rare disease. Even if one data, you fail to de-identify, that there's the chance of, showcasing the patient's details. But I wouldn't say it is not possible. We just need to slow steps. We need to start showing them, okay, this is how it's done. 95% it's done, which means 1% somebody has to check. But the other challenge, as with all the ML solutions, right? How do we identify that 1%?
Sure. Okay, interesting. Okay. And then just a follow-up question. So there are different models available, and it's humanly impossible to go and look at the best model. So do you have like a more like a pre-qualification phase wherein you run through some benchmarks for your use case, and then if it meets, you bring in, and then a follow-up would be, do you also do a bit of RHLF, which is reinforcement learning with human feedback? Thoughts on that?
Yeah. So on the benchmark, it's something that is in our roadmap. So that's what we felt is in order for us to compare, like the MedGemma, it's a very unique one, right? Like I know there's models that's been trained on medical data, but it's kind of outperformed. So we knew that, okay, let's give it a try. But over time, let's say there's like 50, 60 models coming in, unless we have that benchmarking data, it's going to be quite difficult for us to. So that's in our roadmap. How do we ensure that? How do we know that which model? It's also to do with the optimization, right? So we might find that a lightweight model is actually doing much better than a bigger model, because the MedGemma that we've used so far is the 7 billion model. We've not even jumped into the 27 billion. So if, there's lots of things that we need to start benchmarking, which is in our roadmap, but agree to that. Otherwise, it's very, very difficult.
Yeah.
To the next question is, at the moment, even though we have GPUs, we try to start simple. We try to do first with, does it even need an AI solution? Can we use rules? If not, the next step, still classical NER models, and then we go step by step. We haven't tried, I wouldn't say we won't, so it will be still part of the research work, right? But the other thing what I'm not sure is, because I know we have large volumes of data, but the variability is going to be quite less. So trying to fine tune that, would that help? We need to explore.
Interesting. Okay. Thank you for the responses. Just opening up for the questions. Any other questions from anyone else?
Yeah, Prakash here. Can I? Uh,
Yeah,
thanks
go
for
ahead.
thanks for the excellent presentation. It was very thorough. I would say, given that you are a what do you call it, technical person, and there is subject matter expertise, which is obviously a territory which is not ours. In the case of uh, people who are not medically trained for it, are healthcare persons. So, question from my side is, I saw some of the matrices or metrics which you use, like confusion matrix types, heat maps, and the other thing is I observed that for classification you had used some of the what do you call, the machine learning like tree-like structures and all that for classification and all. So in terms of technicality, how do you find the like you said, selectivity is one of them, precision is, what kind of metrics is more important? Is it more important to ensure that there is no false positive, or is it more important that it is uh, some other criteria in terms of the confusion metrics which we use for generally for a beta? You say that you have a beta of 1 or zero point 0.5 or 2. Does it improve anything? That kind of thing which you observed in medical terms, in terms of medical outcomes or conclusions that you made?
I think it's
You can take kidney as one of them which you started, or it
yes,
could take another of the one.
Yep. So I think it would depend on use case by use case. Because if we think of, so one of the other solutions that we did was an operational one, which was to kind of automate sentiment for the feedback. So there's a system called Friends and Family tool within NHS, where they collect feedback from patients and families. So in our case, children used to write their own feedback. So there, the metric is, even though you're trying to predict the positive and negative, it's not as crucial as you. So if you think about it, if you miss a positive comment, like it's not going to have a huge impact, right? You've missed a positive comment. Whereas if you take the histopathology, even if we don't identify the entities correctly, it's fine. But misclassifying them would be a major issue. So even if we go and tell the clinicians we have a tool, 80% it's able to pick, but 20% it cannot pick, it's fine. But if we say 80% it's able to pick, but it also includes misinformation, that's high risk. So they were so when we were working on tumor reports, and when we were trying to use the zero shot, what the model was not capable of doing was, when it finds the word no tumor present, it would highlight it as an entity. But in the same report, for a particular organ, you would also have something called 95% viable tumor. So that would be missed. So if technically you could say that it's able to pick part of the entity, but from a clinician's perspective, that's completely wrong. If you have information that says that there's no tumor present, but on one particular organ there's a tumor present, it needs to infer that there has been tumor. So it will kind of, it depends on the use case that we are working on. And also, like 100%, no machine learning solutions is going to be perfect, right? So what clinicians always want to understand is, they don't mind it making a mistake, but why did it make a mistake? Where is the weakest point? We need that explainability.
So
I
by
I
increasing
answered.
you answered it definitely. By adding more keywords to the uh, your inferencing or classifying, does it help? Like example, you are more worried about out of distribution, which is what causes the main problem,
Yeah.
right? So your main data, so whatever is uh, you can, is there not a way to separate out the out of distribution and then manually get them investigated before you bring
I
in
Yes,
back?
I think that's what's very interesting is, because gosh, they are specialized in looking after children with rare conditions. Even if you look at the past 10 years of data, and then a report or some information from next month, it would look completely different.
So is it so dynamic in the
Yes,
sense? Okay,
yes.
okay.
And
So
especially
if
because it's pediatric, I think it's more
Mhm.
complex. So I won't say, like, at this point with all these AI technologies, there's definitely lots of positive progress. But are we there yet? I think that's, like, compared to other sectors, this complexity, the more clinical information we gather, it's also like, even if we are not able to make it perfect already, if we are able to explain, like, let's say in histology reports, this model is not good at picking out diagnosis, but it can pick the number of glomeruli, then that's a good information for the clinician.
okay, so there has to be some feedback to improve. Okay, got it.
Yes, yeah,
Thank you. Okay. Very good presentation.
thank you.
So, Pavi, there is one other question. The question is about technologies that were used.
Technologies. So as I said, everything's open source, PyTorch, Python, code from scratch, making sure that we don't have any API calls. So all the models, we have our own ML flow set up within our infrastructure. So the models sit there within the ML flow. We have our own in-house annotation tool that the clinicians can access.
Interesting, thank you.
Yeah,
Any other?
one more question. So going forward, what uh, what is the thing that you would like to do to improve the outcomes? Basically, outcomes are very important in uh, medical or healthcare because everything is based on uh, outcome. So how does it contribute to reducing the time to diagnose? How does it improve healthcare for the organization to invest more? Are there anything you have thought about or in the roadmap you have?
So so as I said, like as I was showing, the one of the key things, at least for me, something that I've learned is no matter how much you invest in technology, adoption of it is very, very different, right? So this is where we are looking into user interface. I know it's completely, we might think like, I'm a machine learning scientist. Why should I be building apps, right? So, but when we started exploring user interface, then you also have this human computer interaction. What does a clinician want to see? What will make their lives easier? How easy is it to kind of align it with their clinical workflows? Also, the feedback loop that you mentioned, Prem, is there a way of collecting it? For example, if we take an imaging solution, we might want to draw a bounding box. It might not do well now, but let's say we pilot it as a triaging tool. How do we also collect information from the clinician that will help improving the model? So that's one thing. And to answer your question, Prakash, to improve it, what we've now done, as I mentioned, is we are now looking into this monitoring framework called statistical quality monitoring. So the papers published in the European Conference for Machine Learning this year. I can share it with you, Prince. Very, very, it's quite technical. But what we want, what we are aiming there is if we have a monitoring tool that can look through all these components, all the metrics, and tell us, okay, this is an outlier. This batch of data is an outlier. This should not be sent to the clinician. This has to be reviewed. So that's like the next step that we are looking into.
Essentially, I would add, so you are saying that it's not nothing to do with just language models. It can also involve visual
Yeah.
and possibly human-computer interaction, which you can get more value out of the
Yes.
clinician's time, which is
Yes.
very important.
Yes. Because if we think about it, it's not just about visually showing them a screen, right? What exact? So we might have tens and hundreds of metrics from our side. What does that matter to them? You know, they're very, very busy. What exactly should we show to them? It could be like a histogram or, you know, like even simple things like, do they need a number? Or do they need to understand that this is uncertain? And also the explainability. How do we explain? How do we ensure that this is how the information has been captured?
Super,
But then if you
super.
give too much of information, it's like reading a report for them. You know that there's lots of open-ended questions. So we are also now working with research students, research. We collaborate with UCL a lot. So we are trying to kind of, you know, like this is where like there's lots of research components that we are trying to bring into practice
Mhm. Excellent, excellent, very good. Yeah, thoughtful.
One more question, the total time it took
for
to the
this
end.
research. Like if this was done in a corporate sector, it could be done in a proper sprint, 6 months, 3 months, right? But again, there's two things to it. One, within NHS, it's going to be quite slow. So every project that we do takes like a year and still would be ongoing. But the whole research and analysis, I think it also kind of differs. Like when we started from scratch, when this team was focusing on AI, that's when we built the infrastructure, which took us almost more than 6 months to have the infrastructure in place. And then working on projects was like from scratch, you know, like trying to understand the data, the domain, and now we have a process in place. So we are trying to be more and more efficient, but I think it also depends on the domain as well and clinicians' time. And lots of failures. As ML people, we should embrace that. Is you know, like hundreds of experiments failed before we find the eureka moment. Right. In terms of the data for the histopathology, if we take it as an example, it was like past 10, 15 years of retrospective data. And infrastructure used is we have our on-premise service. So we have 3 CPU machines where we develop the code structure on where we can access de-identified data, and we have 2 servers specifically for piloting on identifiable data running our experiments, which has a H100 GPUs.
Can I ask a specific question?
Yep.
So this link was shared by Prakash. If you just let me know what's the purpose of the meeting, that will be a little bit helpful for me to understand. So I have fair amount of background in AI, ML, on-prem hardware, Cerebrus, and all of that stuff. So you can be very quick also.
Yeah, so Sachin, thanks for joining the call. So this is more like a community around agentic AI.
Okay.
We primarily focus on getting into the details of how people build agentic AI, their experience, and also some of the know-hows. This is a series of meeting. We meet every month, once or twice.
Okay.
And we have industry experts, like, for example, today Dr. Pavi is presenting about her experience in using AI in healthcare. So that's sort of the community is all about.
Oh, beautiful, beautiful. So I am building something that can run probably like 1,000 agents, SLMs, and which are coordinated by Claude, Opus, and the Fable at the highest level. And this goes acyclic DAG, and you can use any accelerators in that. So at some point, I think we should kind of talk offline. So I was having this conversation with Prakash, and he just told me that this is something that might interest you. I'll go off the call, but I'll be listening. So thanks.
Thank you. Yeah, if there are no more questions, thanks everyone for joining, and thanks a lot, Dr. Pavi. This is quite a eye-opener, at least for some of us who are on the technology side. Right? So the future sessions, just to talk about that. So the next session would be on the spec-driven development. This will be given by Shivel Murugan from Microsoft, and then we also plan to have session around particularly on the harness system, because that's one other important area that's gaining a lot of traction. And also looking forward to volunteering. I mean, anyone who wants to talk on any topics related to Agentic AI, please feel free to reach out to me. Again, this is an open community. Okay, thank you. Thanks everyone for joining today.
Thanks everyone, and thanks Pavi for the excellent presentation.